Welcome to MindTier Learning, where we make GCSE learning and revision simple and effective. In this session, we'll explore strategies to help you understand key concepts, manage your study time efficiently, and build confidence ahead of your exams. Let's get started on the path to success. Welcome to today's lesson on rivers from source to sea. In this lesson, we are going to follow a river on its full journey, from its source in the uplands all the way to its mouth, where it enters the sea, a lake, or another body of water. A river does not stay the same throughout its journey. It changes in size, shape, speed, power, and the type of material it carries. At the source, the river is usually narrow, shallow, steep, and rocky. By the time it reaches the lower course, it is usually much wider, deeper, and more powerful. To understand these changes, we are going to look at two important ideas: the long profile and the cross-section. The long profile is the side-on view of a river from source to mouth. The cross-section is a slice across the river channel, showing its width, depth, and shape. The big question for today is, how and why does a river change from source to sea? Let's begin with the learning objectives. By the end of this lesson, you should be able to do four things. First, you should be able to identify the characteristics of a river's long profile. That means understanding how the river changes from a steep upper course to a gentler lower course. Second, you should be able to explain how cross-sections change as a river moves downstream. A river channel usually becomes wider, deeper, and smoother as it moves towards the mouth. Third, you should be able to analyze the relationship between velocity, discharge, and sediment. Velocity is the speed of the water. Discharge is the amount of water flowing in the river. Sediment is the material carried by the river. These three things are linked because a faster river with higher discharge can usually carry more material. Finally, you should be able to contrast the theoretical graded profile with reality. In theory, rivers try to develop a smooth concave curve from source to mouth. But in reality, rivers often have sudden changes in gradient called nick points. So this lesson is about seeing the river as a system that changes continuously as it travels downstream. Before we go further, let's look at the key vocabulary. The first term is long profile. The long profile is the side-on view of a river's course from source to mouth. It shows how the river's height changes along its journey. The second term is cross-section. A cross-section is like taking a slice across the river channel. It shows the shape of the channel, including its width and depth. The third term is stream velocity. Stream velocity means the speed at which water flows through the channel. It is usually measured in meters per second. The fourth term is river discharge. River discharge is the volume of water passing a particular point in the river. It is usually measured in cumx, which means cubic meters per second. These terms are important because they help us describe and explain how rivers change downstream. Before we travel downstream, let's recap how rivers move material. In the last lesson, we looked at how rivers transport and deposit sediment. A river uses its energy to move material downstream. This material is called the river's load. The golden rule is, when velocity is high, the river can transport and erode. When velocity drops, the river loses energy and deposits its load. There are four main transportation processes. Traction is when large boulders are rolled along the riverbed. Saltation is when smaller stones bounce along the riverbed. Suspension is when fine particles such as silt and clay are carried within the water. Solution is when dissolved minerals are carried in the water. These transport processes matter because they help explain why rivers change downstream. As a river becomes more efficient, it can carry more material. But when it loses energy, it has to deposit some of that load. Let's do a quick recall. Question 1. Which process involves boulders being rolled along the riverbed? Question 2. When a river loses energy, what process occurs? Question 3. What happens to the capacity of a river if its velocity increases? Take a moment to think. Remember, capacity means the total amount of load a river can carry. A faster river usually has more energy, so it can carry more and larger material. Let's go through the answers. For question 1, boulders rolling along the riverbed is called traction. For question 2, when a river loses energy, deposition occurs. For question 3, if a river's velocity increases, its capacity also increases. This means it can carry more load and often larger particles. This is important because river landforms are shaped by changes in energy. When the river has lots of energy, it can erode and transport. When it loses energy, it deposits material. Now imagine you are a droplet of water at the source of a river, high in the Pennines. At this point, the river is close to where it begins. The channel is small, shallow, and narrow. The land is steep, and the river may be flowing through a rocky upland landscape. Now imagine that same river much later, near the North Sea. By then, the river is much wider and deeper. It has been joined by tributaries, so it carries far more water. It may flow through wide floodplains and large towns or cities. So the question is, why is the river shallow and narrow near the source, but wide and powerful near the mouth? The answer is that the river undergoes a physical transformation as it moves downstream. It gains water from tributaries. It erodes, transports, and deposits sediment. Its channel becomes smoother and more efficient. Its valley changes shape. We measure and describe these changes using the river's long profile and cross sections. A river is usually divided into 3 sections: the upper course, middle course, and lower course. The upper course is near the source. Here, the gradient is steep. The river often flows through V-shaped valleys. The channel is narrow and shallow. It may contain large, angular boulders because material has not yet traveled far enough to become rounded. The main process in the upper course is often vertical erosion, where the river cuts down into the landscape. The middle course is further downstream. Here, the gradient becomes gentler. The channel becomes wider and deeper. The river begins to develop meanders as lateral erosion becomes more important. The bedload becomes smaller and rounder because of attrition. The lower course is near the mouth. Here, the land is much flatter. The river flows through wide floodplains. The channel is very wide and deep. Discharge is high because many tributaries have joined the river. The river is usually more efficient and carries finer sediment, such as silt and clay. So from source to mouth, the river becomes larger, smoother, and more powerful. Now let's deal with a common misconception. Many students assume that river velocity decreases downstream because the slope becomes flatter. That sounds logical, but it is usually not correct. In many rivers, average velocity actually increases downstream. Why? Because the channel becomes more efficient. In the upper course, the river channel is shallow, narrow, and rocky. There are lots of large boulders, and the riverbed is rough. This creates friction, which slows the water down. Further downstream, the channel becomes wider and deeper. It has a larger hydraulic radius, which means less of the water is in contact with the bed and banks compared with the total amount of water in the channel. The bed also becomes smoother because large boulders have been broken down and transported. This reduces friction. So even though the gradient is gentler downstream, the river often flows faster because the channel is deeper, smoother, and more efficient. A useful comparison is a bumpy wooden slide versus a smooth water slide. The upper course is like the bumpy slide, steep, but rough and full of friction. The lower course is like the smooth water slide, less steep, but much more efficient. As a river moves from source to mouth, several variables change in predictable ways. This is often shown in the Bradshaw Model. First, channel width and depth increase downstream. This happens because tributaries join the river and add more water. More discharge allows the river to become wider and deeper. Second, average velocity increases downstream. As we have just discussed, this is because the channel becomes smoother, deeper, and more efficient, with less friction from large rocks and rough banks. Third, bedload size decreases downstream. Near the source, the river may carry large, angular rocks. As these rocks are transported, they collide with each other and with the riverbed. This process is called attrition. Over time, the rocks become smaller, smoother, and rounder. Fourth, total discharge increases downstream. This is because more water enters the river from tributaries, surface runoff, through flow, and groundwater flow. So the general pattern is, the river becomes wider, deeper, faster, and carries more water. But the individual pieces of sediment usually become smaller and rounder. Now let's test your understanding of downstream trends. You need to rank these river characteristics from decreases downstream to increases downstream. The characteristics are channel depth, channel roughness, total discharge, bedload particle size. Think about what happens as the river moves from source to mouth. Which things become smaller or lower? Which things become larger or higher? Remember, Bed load is broken down by attrition, while discharge increases as tributaries add more water. The correct order is: first, bedload particle size. This decreases downstream because rocks are broken down by attrition and become smaller. Second, channel roughness. This also generally decreases downstream because the channel becomes smoother and more efficient. Third, channel depth. This increases downstream because the river carries more water and the channel becomes larger. Fourth, total discharge. This increases downstream as tributaries add more water to the river. So the key pattern is: sediment size and channel roughness decrease, channel depth and discharge increase. This is a useful pattern to remember for GCSE Geography because questions often ask how a river changes downstream. Now let's look at the idea of a graded profile. In theory, a river works towards creating a smooth, concave curve from source to mouth. This is called a graded profile. A graded profile represents a state of balance or equilibrium. In this balanced state, the river has just enough energy to transport its load. It is not eroding too much, and it is not depositing too much. The river is constantly adjusting itself. If it has too much energy, it may erode. If it has too little energy, it may deposit. The ultimate base level for most rivers is sea level. Base level means the lowest point to which a river can erode. Most rivers cannot erode below the sea they flow into, because the sea acts as the final level for the river system. So, in theory, the long profile becomes a smooth curve that gradually flattens towards the mouth. However, real rivers are more complicated than this. Does every river have a perfectly smooth curve? Rarely. In the real world, rivers often have sudden changes in gradient. These are called nick points. A nick point is a sharp break or change in the river's long profile. One cause of a nick point is a band of hard rock. If a river flows from hard rock on a softer rock, the softer rock may erode more quickly. This can create a waterfall. Another cause is a dam or reservoir. Human structures can interrupt the river's natural profile and change how water and sediment move downstream. Tectonic uplift can also create nick points. This happens when land is pushed upwards by movements in the Earth's crust. If the land rises, the river may gain energy and start cutting down more rapidly. So while the graded profile is a useful theory, real rivers are shaped by geology, human activity, climate, and tectonic processes. That is why rivers are never really finished. They are constantly adjusting. Now let's apply your knowledge. The question is, why does the bed load at the mouth of a river look like fine sand or small rounded pebbles, while the source is full of jagged boulders? This is asking you to connect river transport and erosion processes. Near the source, the river is in a steep upland area. Weathering and mass movement can add large, angular rocks to the river channel. These rocks have not yet traveled far, so they are rough and jagged. As the river transports them downstream, they collide with each other. This process is called attrition. Attrition breaks the rocks into smaller pieces and smooths off their sharp edges. The rocks may also scrape along the riverbed during transport, which is linked to abrasion. By the time the material reaches the lower course, much of the large bed load has been broken down. Only smaller, smoother, and more resistant particles remain. Fine materials such as sand, silt, and clay may be carried in suspension or solution. So the change in bed load from source to mouth is mainly caused by transport distance, collisions, abrasion, and attrition. You might have said that at the source, mass movement deposits large, angular rocks into the river. That is correct. You might also have said that collisions during transport cause attrition and abrasion. That is also correct. Attrition makes rocks smaller, smoother, and rounder as they hit each other. Abrasion can also wear them down as they scrape against the bed and banks. By the lower course, the river has transported the material for a much longer distance. Larger, weaker rocks may have broken apart, leaving smaller and more rounded particles. A strong GCSE answer could say, at the source, large angular rocks enter the river through weathering and mass movement. As they are transported downstream, they collide with each other and the riverbed. This causes attrition and abrasion, which break the rocks into smaller pieces and smooth their edges. By the time the river reaches its mouth, much of the bed load has become fine sand, silt, or small rounded pebbles. That answer is strong because it explains both the starting condition and the processes of change. Now we are going to bring everything together with a summary task. You need to sketch a diagram of a river's long profile. Start with the source high up on the left-hand side of your page. Then draw the river profile sloping down towards the mouth on the right-hand side. The shape should be steep in the upper course and gradually become flatter towards the lower course. It should look like a smooth concave curve. Next, label the upper course, middle course, and lower course. Beside each label, draw a small cross-section of the river channel. For the upper course, draw a narrow, shallow channel, possibly in a steep V-shaped valley. For the middle course, draw a wider and deeper channel. For the lower course, draw the widest and deepest channel with a broad, flat floodplain. Finally, add an arrow to show where the highest velocity is likely to be found. Remember, the highest average velocity is often found further downstream, where the channel is smoother, deeper, and more efficient. This task helps you connect the long profile with cross-section changes and river processes. If you found this presentation helpful, please remember to like the video and subscribe to our channel. Your support means a lot and helps us bring you more valuable content. Thanks for watching.